Hey everybody, this is Larry. This is weekly contest 188 for Leetcode. We have 30 seconds to go, so take the time to hit the like button, hit the subscribe button. Feel free to, there'll be links below for you to jump around the video. There'll be explanations near the end and stuff like that. It's a live, so, uh, wish me good luck and hope you have a good contest. Let me know if you have any feedback, questions, or just let me know how you did. Hope you had a good contest as well. And well, let's go. 4 seconds. Cool. And here we go to a loading
no,
screen. Okay. Cool. Build an array with stack operations, Q1. So this one, so the idea is that because I think this is a weird problem because there are a lot of different statements that each of them makes the problem easier, but you have to read a lot for this one. So the thing is that it's guaranteed the target array was strictly increasing, which I'm misreading here.
What?
Until maybe it's actually I only noticed now that it's in the constraints itself, but I knew how to do it in roughly even now, so I don't know why it took so long in this one, but it's just a lot of reading to make sure. But it's pretty much for each number. So I just go from 1 to n. Not quite yet, I suppose. But I just go from 1 to n. And here, right now, I double check that it is strictly increasing because I remember reading about it, but I wasn't sure. So yeah, so now I go from 1 to n. And there are only two cases, right? Because it's increasing, which is whether a number is in target or it's not. And you should even put it into a collection, a set of some sort. But I didn't because and it becomes n squared, but n is only 100, right? So if n is 100, then it doesn't. Then it's going to be fast enough. So my logic was just let's not think about it. But if the number is in the set or list, then you do a push. If not, then you do a push and then a pop and those are the two cases only. And actually, you cannot. There's no other answers. The only thing that you have to keep track of is, well, if you don't have the last few numbers, you have to remove them. So I think I did it kind of, so this is actually wrong. I think that's how I end up taking some time. And I had to look at this and I was like, oh wait, this is not the way to do it. And I think you could have used what I did with respect to the last two elements, but one is I have to get rid of the 0, but I still see these issues. And the thing I needed to do is to remove or just keep track of the biggest number that we've seen and remove everything afterwards. And that's what I end up doing. I think in the contest at this very moment, I tried a little bit too hard to come up to fix what, or I knew I could still done the while loop method here, but I was worried about all the edge cases. And then here I'm thinking, well, what are the trade-off in typing and thinking about the edge cases and so forth. So I just end up using a second element. And I think I did definitely try to rush this a little bit because it is easy and usually I get it within a minute or two. But today, I think the contest is also slightly harder, but today I was just not really 100% really, but that's okay. So you will have those days. But yeah, now I'm just double checking to make sure that it's good. So I did take some time
slow today.
Yeah. Q2, count triplets that can form two arrays of equal XOR. Given an array of integers, okay. Oh yeah, so this one, well, I feel a little off. Maybe all the sniffles in the beginning as well. But this one, I think I spent some time trying to figure out whether I can do better than n cubed. So n is 300, right? which n cube is 27 million, which is really cutting it close. But then it took, and I was thinking about how to do it, and then I ended up doing it with C++, um, because I thought that n cube at the time, I thought n cube would be 27 million, which is cutting it close. I think for Leetcode for n cube, maybe you could get away with it, but it depends on how strict or not strict maybe the test cases will be, and just wasn't confident about that particular piece. And now I'm in this moment. I'm thinking about, well, can I do better than n cube? Uh, yeah, and I was like, maybe not. Let's do C++ so that if there's ever a running time thing, then I could, you know, then I could just, it wouldn't be like it wouldn't factor in as much if that's the intended solution. So yeah. So now I'm just setting up the array. I would say, so the reason why I took 10 minutes on this problem, I think, is actually because I did it with prefix sum. Um, so you definitely can do it with prefix sum, and in the explanations later, I explain why prefix sum works. But looking back right now, looking at my thing, and you kind of see me hinting at trying to do this, but I was just really worried about off by once that I didn't really think it through. In retrospect, I should have did what I am doing here, where I didn't really need the prefix sum. I could just calculate on the fly, um, but I just wasn't doing it quite right. So now you see me doing prefix sum. Looking back, I probably spent 5 minutes about this because I was doing it with prefix sum, which is correct, but it was not necessary. What I did before with the int a, um, like like calculating just on a streaming basis, as long as you don't put in an additional for loop, you're probably okay. And that's probably why it was a Q2, and I made it more difficult than it needed to be, um, because I think actually, I think I just to be honest, I think I rushed it a little bit as well, mentally, even if it doesn't seem like it, because that led to me uh, just, I don't know, like I feel like I was not optimal in this problem. And I here now just want to double check the I, J, and K. Um, oh yeah, and I spent a silly amount of time on. Well, this one is okay. I think I was just thinking about off by one, which at this point I spent way too much time on this. Um, but but I should have known. The other thing is that I should have known better here is that so actually I think I mostly got the um, think I mostly got the index right. Like I knew what to look for. But the problem is that if you're really good at bitwise operations, then you'll notice what I'm doing wrong. And usually I'm better about this, but again, today maybe it's just one of those days where a little bit silly. So I went and I was like, okay, that's way not right. So um, now let's print this out. But the short answer is, well, okay. See if you could spot the bug immediately. Let's say there's no off by ones. So see if you could spot the bug. Leave a comment below if you spot the bug before I actually do it, before I actually fix it. But yeah, I was like, okay, maybe there's an off by one. Which that one actually, I think I was like, okay, but it's still not right. And now it is about 10 minutes in. I end up spending at least 3 more minutes on this silliness. But I think if I just not did prefix sum, this would have been a much faster problem. Um, Here I printed out, I was like, wow, this is a lot of stuff. And I had to mentally just figure out where the indices are. I spent, there's a lot of time wasted on this one. I think if I had been able to submit when I did, um, then this would have been an okay problem for me. I mean, like the problem is okay. It's just I would have considered it that I did okay. But this debugging was painful. And yeah, see if you could spot the bug because I took me a while. So maybe that's like a fun challenge at home. Uh, and in a fun way, this debug statement actually does not help at all. Um, like, that doesn't make sense. Well, it does by omission maybe. um, so if you caught it before I fixed it, mad props to you because I really took a while. But the answer is that the equal operation has higher precedence than the bitwise operations. Um, so so yeah, and now I'm able to be like, okay, at least it is more correct. I might have an off by one, but at least it's more correct. And now I'm able to use my debug code to be like, okay, where am I off? 0 to 1, that should at least be a 2, so I have an off by 1 there. Um, I also recommend in general just printing out stuff because you have to learn how to debug. Not every contest, not every interview is going to go 100%, and you want to prepare even those cases that you do well. And off by once is definitely a place where, well, things happen. And here I'm looking at the constraints again because I'm like just making sure that I didn't misread it. But I think I don't know. I wasn't focusing on the right energy because that doesn't make sense of the output. Yeah, looking and then the answers looks good. So I submit and that was a hard problem for me. Okay, Q3. Minimum time to collect all apples in a tree. So this one you're given a tree, but it's not a well, it's an apple tree, but you're not giving a tree data structure. And when I refresh, I was like, wow, 40 people already finished this. I'm really slow on today because people, you know, that's intense. But Yeah, now the first thing I do is I convert it to an adjacency list. I think one thing to note is that it's not clear that it's a binary tree, and I think I tried to be sure that it doesn't seem that way. So now I just construct a adjacency list. Um, so as a reminder, if you want an explanation on this problem, skip a little bit ahead or click on the video that's for this problem specifically, and there'll be an explanation there. And let me know. But for now, I'm just going to talk about my thought process as I go. Which for now I'm just reading the problem. I just want to make sure that I'm reading it correctly. And at this point, I'm just looking at the input just to be like, okay, let me make sure that everything's okay. But after that, I was like, okay, I could just do a depth first search. And that's essentially what I started already. Look at that game face. uh, and I spent too much time just trying to figure out the naming for this problem, for a helper. Basically, at this point, what I wanted was, okay, given a node, what's the recursion? Well, the recursion should be some variation of, um, and I was trying. I mean, I knew it was going to be some sort of recursion or depth first search, if you want to call it that. But I was like, okay, what are the base cases? And that's what I was trying to type out a little bit. I was like, that's not a base case, um, and because we have not a tree, not a node or vertex data structure, we have to visit it. So we kind of treat this almost like a general graph in that we, for our depth of search, we have to make sure that we haven't seen the node, and that's pretty much what we do here. And we have a helper function of apple, right, for a node. And for me, this apple node is for this apple function just calls if this tree or its subtrees have apple, have any apple, then mark that as true. So a better function name for this would be apple in subtree or something like that. And you could probably calculate this with another way, but I did it with LRU cache. The reason being that we know that for Apple, there are only n vertices, and you want to calculate each of them at most once. So that's what I do here. And here, I think what I'm struggling with is coming up with a recurrence, right? I mean, the recurrence is simple. It's giving every node, look at the subtrees, and then if any of those subtrees have an apple, then return true. And you could calculate that recursively because, by definition, if any of your if any of your child, if any of your children, it's true, then go for it. Then it is true for this node. The problem is that I was just still trying to figure out, like here, like okay, in this sense, because it's a second depth first search, like how do you maintain the state of stuff that you've seen and you haven't seen, and you keep track of them together? And that's what I'm trying to do here in a really funky way. And I think I think like halfway through, I'm like, I don't know if I could like prove that this is correct or that like it's good enough to be true. So I'm just trying to figure out how to do it here. And then I was like, if I do this, it might not be, but then it might still go up the tree because, or something like that. Those are the things I'm worried about when I'm doing this, just in terms of edge cases and carefulness. And here I was like, okay, we don't want to create a copy if they're in scene, just so that it saves a couple of cycles. But yeah, and I'm still trying to figure out how to use this, and I'm like, I spent a lot, as you could kind of tell, I spent a lot of time thinking about how to do this, mostly because I wanted to avoid the obvious of just creating a tree myself. And I was like, okay, if I just want to create this tree where it's a directed graph, how do I go about that? All right, let's just go through a depth first search and remove the remove the back edges upwards, starting from 0. So that's what I did with this depth first search. It's a little bit terrible naming, but during the contest, I was just like, okay, just get it done. You spend a lot of time on this. And basically, you could see that for every node, remove the back edges that are coming back from this or to this edge, and that's what I do. A couple of things is that you notice there's a typo, and also we're using list, so I was like, okay, actually I could probably just convert it to a set, which I do in a second after I fix this code. So the recurrence is right, and maybe that's a problem today in general. I feel like I got all the algorithms pretty quickly and pretty correct at the end, but my implementation is just off today, which I guess maybe you just have one of those days sometimes. Um, yeah, and now I do spend and yeah, I noticed that I used the wrong function name there, but yeah, I spend too much time on this in general. Because here I should have been able to submit if I was correct. There's no set, so yeah, I have to change the function name. Okay, but now maybe I should have been able to submit if I was accurate. But if I get maximum depth recursion, which is actually I think a blessing in disguise, because for 100,000, actually I think if I didn't have it in a weird way, if I didn't have an infinite loop, um, I would have gotten a wrong answer because of the recursion depth, because I forgot to think about it. And now I'm just copying the the case from before, because I was like, oh, actually, and it was a reminder. Like I knew that it wasn't going to solve my issue, but it was a reminder that n is 10 to the fifth or 100,000. So I need to do this thing anyway, otherwise it's not going to make it. I just chose some really big number. It actually doesn't really matter what the number is as long as it's bigger than what you need, because at some point it would crash without memory anyway. So then, like, yeah, for competitive programming, it doesn't matter. I guess it's maybe a better way of saying it, because it just runs out of memory before it runs out of stack. Uh, but yeah, but now I'm like, wait, why? Why is this not working? The, See if you can spot this bug. That took me a couple of minutes. Um, I commented it out just in case, so that, well, just so that printing is a little bit easier. And I was like, okay, this is definitely going back and forth. So the definitely now it's like, okay, wait, what is wrong with this? Well, the thing is that you keep on calling itself. I ran it again, still the same thing, and I was like, oh, why? Do I have another bug? Yeah, I do have another bug. See if you can spot that one too. Uh, but yeah, so in general, yeah, I mean there'll be an explanation later in the, if you click forward in the links below. But that's kind of my thought process for this problem. Um, yeah, after printing that out, I'm like, oh, this doesn't print at all because we don't call it at all. So that's the bug. That took me a couple of minutes. So just a lot of silly implementation things that actually, when I ran the code, I was like, oh, I'm surprised that this actually. Uh, I'm just surprised that this actually ran. And I brought back the recursion limit. And that, I mean, I'm also surprised that this was ran the first try kind of after that, because I just struggled a lot. So I submit, and it was good. Q4, number of ways of cutting a pizza. Okay, so this one I'm just reading a little bit. Yeah, still reading. So I think I tried to read, but I skipped a little bit ahead. I think the problem was that I misread this in the beginning a little bit, in that I didn't read the part where you only give the left and the top. So I was like, oh, maybe I could, like cut it off and then take the left part instead of the right part. And then in that case, it's a much harder dynamic programming problem in which you have to spread the cuts around. But in general, when I saw this, I immediately knew it was dynamic programming. I saw K is 10, so I was like, oh, maybe there's an easy way to take advantage of that. But yeah. Yeah, still reading this problem, and because I was thinking about the harder problem, I was just trying to figure out how to optimize it in my mind. I refreshed. I was like, okay, like enough people solve this. It should be easier, right? Like a little bit better on that front. But hold on, I might have did the shortcut by accident. But yeah, but now I'm just setting up the matrix while I'm like looking at it. I'm still thinking about this problem at this point. I think I still have not seen the cutting off, because if you don't cut it off, then I was thinking about like subregions, and there's too many states for that. But yeah. Yeah, now that I reread it, I was like, wait a second. You could only
Oh, I missed
you
prejudice.
yeah, you only cut off the left and the upper part. So I spent about I spent about 4 minutes just on misreading that problem. I was like, oh, this is easy. This is obvious now. Still took me a lot of time after that, but still. Uh, but yeah. But I knew immediately how to do it. Kind of. I mean, the implementation is a little tricky, and I was a little bit slow on this one still. Uh, and here, I mean, it's one of those things where you do enough times, you just kind of have a blind spot. I I misused LRU cache in this case, and it cost me a wrong answer. You could, if you're an expert or just practice, you may have noticed, but yeah. But here I'm just going through what the base case is. I was like, okay, if and this is just very common. If you go to the end with the x and the y, then you're done maybe. But in this case, actually maybe no. So that's why I wrote the base case. I'm like, no, that doesn't really make sense. That's not quite right. Um, our base case should be that if we have no cuts left, and there are apples on the pizza or something like that. But yeah, what was apple? But yeah, but now we what I did was just say that um, yeah, if I was like trying to figure out if I should implement it with a for loop by counting the pizza input, but I was like, okay, let's just put in an abstraction. If has apple on xy, then return one, otherwise return zero. Here, I was trying to think about the off by one. Um, so I have an off by one here as a result, but I was still trying to think through how to handle it. And also, thankfully, I remember about the mod at this point. Um, because I don't know, I almost forgot to be honest. But I guess summing count maybe I would have remembered, and that's what I did, I guess. Um, but yeah, but yeah. Right now, I'm just going through what it means in terms of uh, like now I'm actually defining the region that we want to calculate hash apples for. And I was just thinking through what that would look like with off by ones and stuff. And also at this point, I already thought about doing it with prefix sums. Um, but yeah. But yeah, I wasn't sure about the off by ones in this situation. I should have. I spent too much time thinking about it because I didn't really define my API as well. But that's also something that I think I rushed a little bit because I probably could have spent a little bit of time clarifying the reason why like off by ones come up when you don't know exactly what your API is. Um, and I think in my mind I just was trying to rush this a little bit. And here I finally defined the API, and what I mean by that with the off by one is that I think I sometimes you don't know, or you have to be clear whether you want things to be exclusive or inclusive on the bounds. And once you do that, it becomes easier. But for me, I think in some places I want it to be inclusive, and in some places I want it to be exclusive. And I think that's where I had the issue. Um, and also, this is inclusion exclusion. Pretty standard prefix sum for 2D, kind of. And now I'm just setting up the apples prefix sum. And it's, admittedly, it's been a while since I've done this, so it's a little bit off. It's a little bit, it's a little bit off. but but that's why I printed immediately, because I wasn't confident about it, so that I could just debug it really quickly. Once I look at what it is, then the output, or the what the matrix looks like, then I would know a little bit better. It's been a while. And also off by one, as you can see, because with prefix sum, you have to include the 0, and then things become one index. So it's a whole thing. So there's an off by one, and then you have to add one, and then that's some of the confusion here. But yeah, now that I put out the way, I was like, oh wait, that is obviously wrong. Let's take a look to what I did. I forgot to. I think there are actually two ways to do this prefix sum. I did it the way where you did uh, the horizontal first and then vertical, well, the other way around, vertical first and then horizontal. Um, Otherwise, you get double counting. You can also just do a subtraction or something like that. But did spend some time debugging. But I'm okay with all this because I am a little bit rusty. And to be frank, at this point, we're about half an hour in, and I just woke up, so I'm a little bit tired, haven't eaten yet, and all that stuff. So in terms of performance, I was okay. But yeah, I mean, the only thing that I kind of felt bad about was the LRU cache one, because that was just like a free 5 minutes giveaway, right? And here I'm like, okay, yeah, I need to fix off by ones here. I think I mostly would have gotten this right if I think this actually would have been done. But I was like, I thought this would be, but then I have um, my cores were wrong. Is the reason? Because I think has Apple's had the right API, and later you'll see that. But yeah, it's like, no, that doesn't make sense. Let's print this out. And basically the rest of the video, basically the rest of this problem, I just do some debugging by printing it out, and then I like manually look at the the corners and then be like, oh, is that, you know. And then the only other bug I have here, other than off by ones, which you'll see me try to fix the off by ones in a number of ways, but the only other bug that I have was that LRU cache I didn't have. I made a mistake on the LRU cache. I go into it a little bit more on the second part, on the explanation part. But yeah, feel free to let me know what you think. There's an again, just to be clear, there's an explanation on this problem at the end. So so yeah, but the idea, just to, because we have a couple of minutes anyway, but the idea here is dynamic programming, and the prefix sum part, it's outside its, it's prefix sum on a 2D. So do some research on that. And then the counting part is just, cutting every possible vertical cut and then every possible horizontal cut, and then counting that all together. So that's all that's what this Larry has. Stay tuned for the other Larry, especially for explanations on this problem and other problems. And I will see you later. Hang out with the other Larry. Bye bye. Oh, silly. All that, and I have a silly typo. Okay, well, I was rushing a little bit. Let's see how I did. Wow, not great. Okay. Okay, let's go over the problems. I was very slow on that one, and obviously one wrong answer was not great, and that was a stupid wrong answer. That wasn't even a good wrong answer. That was just like I was not careful because I was just so. I should have tested a big case. I guess I was confident because I had the cash. I just didn't. There was just this really dumb typo. Um, oh well. Is this? Wow, everyone's really fast on that one. I'm actually. I thought that would be that. Like I thought that would give me more time. That people are a little slower. Uh, but I was slow on the other ones too. So it wasn't just that problem. If I didn't get the submission error, I still would have been like 120 or so. That's kind of okay. That's not bad, but not great either. But again, I spent too much time on the other problems, Q2 and Q3. So let's go over it real quick. Yeah. All right, give me a second to catch up. Like breathing wise. Yeah, I was just a slow contest for me. Maybe I just needed more sleep. Um, 3 minutes of these are pretty slow times for me. Uh, but oh well. Cool. Okay, let's just get started then. Build an array with stack operations. Okay. I was slow for sure. Okay, let's go over each problem individually. Bit five. Okay, I guess the number doesn't matter. Build an array with stack operations. Given an array target and an integer n, in each iteration you'll read a number from the list. Yeah. So I was trying to do something clever on this one initially, with just if you had push pop at the end, you could remove it, and you could still do it that way with a while loop. I think, but I think the better way was just to kind of just keep track of when you stop needing to push and pop. And actually you could probably and should have probably used set on this one on the target, but I didn't. So this is technically n squared, where n is the number of targets, but it's okay. It's fast for n is equal to 100. It's fast enough, and the idea is just keep track of the last thing that you pushed, and then that's it. And then for everything else, because it's monotonically increasing or just strictly increasing, even you can just keep. If you don't need a number, you just need to push and then pop immediately. So that's how I do Q1. Yeah. So that's the Q1. Q2. Count count triplets that can form two arrays of equal XOR. Yeah, so this is prefix sums. I took a while because for some reason yeah, I mean, I thought that n cube is a little bit too slow maybe, but it's actually not n cube strictly. It's n choose 3, which cuts down. It's about like 6 times faster or something like that, roughly. So that's why I initially turned into C++. I was like, oh, maybe I needed to be the fast loops, but it turned out not to be necessary. And I think after that, though, even when I was convinced, I was just a little bit off by 1 in certain places. And I think the thing that I had a little needed verifying was that this would work properly. Because I worried that I would XOR a number with itself, and obviously you can do it, but when you do it, you get 0 instead of, and that's what I was scared of. But actually, it ended up being pretty straightforward, and I ended up taking 10 minutes on this problem, but it probably should have been faster. But the idea is that to actually explain the problem instead of just what I did. So in this one, you can note that the big key to solving this problem is noticing that Well, let's say you have some x sub I, XOR x sub I plus 1, XOR I sub I plus 2, dot, 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 A sub, XOR A sub j. So that's equal to A sub 0, XOR A, and maybe we could space it out a little bit, just so that the visualization is easier. And then dot, 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 A sub I, XOR dot, 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 A sub j, right? Something like that, right? Is this whole thing XORing the prefix. This prefix, that's before the I minus 1. Right? Okay. So this is so something like that. And once you do notice that, then, well, it's prefix sums. And maybe you don't even need it, to be honest, because maybe you could do some smart things with the loops. But with prefix sum, it became easier to just focus on my off by ones, because I knew I would have potential issues with off by one because of what I said about the J and the K. And the other thing that was a little bit maybe odd, but maybe not, is that even though I has to be strictly less than J, J has to be less than or equal to K. And I think I did have an off by one, which as soon as I fixed, it was able to submit, but I was still not confident after that. I was just, you know. But yeah, cool. So that, and then after that, you could just try all possibilities of IJK as it's given, and then it's a little tricky to get off by ones right, but that's pretty much it for that one. Cool. That's all I have for Q2. Q3, minimum time to collect all apples in a tree. Yeah, I end up taking 10 minutes on this one. I should have been faster. So for this one, given an undirected tree, you have 0. Also, I was just a little bit careless today, I think, or a little bit off. It happens. We have off days, and because yeah, I mean, we have off days because I think I just have like little weird things. Like here, I spent some time debugging the fact that, yeah, I just had to debug. I just had issues debugging that DFS. I just forgot to call this, and because everything was depending on that part, it took a long time to debug. But yeah, to actually explain the problem again, minimum time to collect all apples in a tree. So for this problem, the way to solve it is, the way I solved it more specifically, I did a depth first search or breadth first search. I did a depth first search. You could use a breadth first search to get an ordering of the tree. And what I did is that I just make sure that the tree only goes one way. And once I have that, basically you're given almost like an actual tree where you could only go downwards. Because before that you may go into infinite loops, which I did. So for that, we look at, well, recursively for each node. What is this saying, right? For each node that you're given, for each edge going outside that node, if that edge leads to an apple, go down that edge. So that's what the 2 is for, because you need one to go down and then another to come back up. And then, you just do that part recursively. And then the apple is just a quick depth first search as well, where I guess I could have done this recursively, but I did it with LU cache because I was a little bit lazy. But you could actually prove that you could just do one recursion in the beginning. But basically, it's this apple is not the same as the input apple. My apple method is just to calculate whether this node this node or its subtrees have an apple. Because if this node or any of its subtrees or children or whatever has apples, or has one apple even, then we have to visit this node. That's what this function is saying. And that's pretty much it. And because I memorized it, this is going to be linear because we only calculate once for each node. And here, similar thing because we're doing this is actually a depth first search. So yeah, and this is depth first. This is just to give me an ordering because it removes the back edges going upwards, and I do that recursively, and that's why I changed to a set. Not sure why I took 10 minutes on this one, but I think I was just being a little bit careful, and I was a little bit silly with the depth first search, so I just didn't call, and I was printing things out trying to figure that out. Cool. So that is problem 3. Problem 4, number of ways of cutting a pizza. So this one I misread a little bit for the first couple of minutes. I didn't misread. I just got distracted by the pretty pictures, I think. And by that, I didn't see the part where I noticed the cutting the pizza into two pieces part. That part comes up a lot, but I missed the part where if you cut it vertically, you give the left part to the person, and if you give the horizontal, you cut the upper part. Because I was thinking of like some things where you break into the left piece and the right piece, and then each of them you have to split the cuts in some weird way. So that's a harder problem. It's a similar problem, but still a harder problem. And and yeah, and that's to describe the problem. So how do you solve this problem? So I solved it with dynamic programming. I mean, with the number of ways being large, you probably know immediately that it was going to be dynamic programming. And even with my wrong interpretation, I knew, or for that one, in theory, it's dynamic programming, depending on your heights and widths and whatever. So it's if you watch how I solved it, I kind of broke it into different pieces. So that the current recursion, the core part of the recursion is that, well, we just try every slice one at a time and count how many ways there are, right? Like try cutting off the top off, the one row off, try cutting off 2 rows off, and 3 rows off, and see how many ways there are. I went in some off by once as well, but another tricky part about this, of course, is that you have to make sure that when you cut off something, you have apples. So for that, I have a second dynamic programming thing where it's also prefix sum, where it's a 2D prefix sum, so that you could answer the number of queries within a rectangle by counting by taking 4 squares and kind of piecing them together. So that's how I did. That's what this has apples does. It looks at the prefix sums and then just calculate the ones that are bigger than 0 by taking all these maths. And then x, y, this is standard-ish prefix sum stuff. But yeah, I mean, I got most of this pretty okay. I even spent time to test, but I didn't test a really big case because I thought because I was worried more about correctness, particularly with this thing because I was potentially having off by once. So I was worried more about correctness than timeout because I figured if I'm correct, then there shouldn't be any timeout. But of course, the reason why I did timeout was because I used LRU cache, but I didn't have the parameter. And what happens with LRU cache? I mean, I knew that this was the case. I just was rushing it a little bit and forgot about it because I think after I typed this out, I wrote the import statement instead of finishing the statement or something like that. And unfortunately, it compiled, so I just forgot about it later. But why that is that LRU cache starts removing elements once it gets over a certain size, and this allows it to not do that. For competitive programming or from competitive programming on Leetcode, this just makes it an easy way to cache. But again, as you saw, if you don't cache enough elements, then some of those elements will get recalculated, and that led to a time limit exceeded. So yeah, so that's how I solved Q4. Overall, I mean, I took 20 minutes. I thought that was okay, but the 5 extra minutes was the painful part. Cool. I mean, especially since it was a silly mistake, right? If I got it wrong, like was legitimate. But like if I got it wrong on something that I just even in edge case, I'd be like, okay, I should have been more careful about this one. But and this one I still should have been more careful. But it just feels it doesn't feel so good. Um, but yeah, that's all I have for Q4. That's all I have for this contest. Okay. I mean, I think let's see. I think this is final. So I'm 175th. Probably could have done a little bit faster. Let's see. Let's play the. Let's play. Yeah, that's. So at least this is tied in, as in that because my penalty it pushes me down. If I didn't have the penalty, I've been 125th or so. I think. Uh, yeah. Ooh. Mm, yeah. If I didn't have, I don't know. Okay. I guess there's some inconsistencies in the matrix, so it's hard to say. Um, but yeah, but I think if I so I lost 50 rank on that 5 minutes. That's why I usually try to be more careful, and that's why you saw me slow down, but not enough. Um, but as a post-mortem, let's see. I think I probably could have gone Q1 maybe a minute faster at least. I'm usually fast about it, but today I'm just a little bit rusty. I mean, I just woke up, I suppose. Uh, Q2, I'm Q10 3. It's with in another problem. Q2, I definitely should have done in faster than 10 minutes. I knew how to do it. I just, um, yeah, I don't know. It's one of these days. But I probably should at least shave 5 minutes off. I mean, 10 minutes is it's very slow for me. Like 5 minutes, even 5 minutes probably feels a little bit slow for that one. But for prefix sum stuff, I always worry about off by one. So it's something that maybe I just need to practice a little bit better on in general. Q3, Q3. Oh, minimum line of tree. So I took 10 minutes on this. Maybe it's okay. I spent like 3, 4 minutes just debugging infinite loops because I was silly. I think I should have done the made it into a tree earlier. That was kind of a tactical mistake because I was like, oh, maybe I could hack around it with things, but I didn't. So in theory, I probably like on a good day, I probably could have been 12 minutes faster on just the first three problem. And this one, um, I think I was okay. Like on the timing, I probably could have been like 2, 3 minutes faster, but the big one is the 5 minutes. So that's for tanning, just to make myself feel a little good. If I could get 15 minutes off, 15 minutes off just by having an average day, then I would have been top 50, which I guess is my where I've been trending lately. So, or that's like my target is top 50 in general. So I think on a reasonable day, I would have been faster. But today's not my day. Some days, and sometimes you have bad days, and that's okay. And when your bad days are still top 200, I guess I'm not. Yeah, so it's been a while since I did one of these code reviews. So let's actually do a couple of code reviews and see where I can learn because I definitely did not solve this contest very well. I ended up at 175th or so. Cool. So the first one, let's see, this is what I look like. Okay. And I think my main problem with this one was just mostly speed. So this looks okay. Um, Let's see. I mean, I think most people did it about right. I mean, they did while loops and stuff like that. It's about the same idea. Uh, they did it pretty fast. Pretty fast. Yeah. Oh, that actually that first one. I mean, I think this is a cool way of doing it as well, which is that if you're at the last index um, of the target, then you break, which makes sense. I don't know why I didn't think of it that way. Oh, well, because I did it the other way um, with looking at the other way. So it's almost like I did the for loop the other way instead. Yeah, well, cool. So the second one, I took way too long. It's just I did with prefix sum, but as you might have saw on the video early on, I was like, oh yeah, I should have just do a running count, um, which is the same idea. And I started it, but I was worried about off by once. I really did not. I just needed to slow down and think about it more. Um, but instead, I end up taking more time as a result. Yeah, similar to kind of these things where you just keep a running track, and then and that's pretty much it. Wait, this is different. Hmm. Well, this is an n square, so that's pretty cool. I have to read about this later. Uh, hmm. Oh, I see what it's doing, kind of. Right? That's actually really clever. That I didn't really think about at all. But basically, the idea is that um, if the current XOR sum is zero, um, then there then there then for every index that's inside that index, like so basically you're given I and J, if yeah, if for a given I and J, then if the running count from like if everything in between is zero, that means all the indexes in between those two indexes will be will be true because that's by like if there's equal, then the XOR will always be. Wow, that is because you're dividing them in halves, and by definition, because you have if A XOR B is equal to zero, that means A is equal to B, and thus and this is and just kind of reworded that back, and it's true for all indexes. Wow, that is actually a great answer. That's I think that's the kind of stuff that you get when you're good at math. But yeah, everyone else, okay, like going, but I still either way. I should have done this really quicker. No, Lakers is known to be good anyway. But where I should have done something like this with the rolling number, but I did not, unfortunately, because I was worried about off by one. But instead, I also went off by one, so that didn't really save me. Um, yeah, same thing here with the n squared. So well played. I learned something today. That was kind of good. I don't know if I learned enough to be able to do it next time, but that's still good. Cool. Now, this is an n squared prefix sum that also does the same thing. So, yeah. What did Alex do? Man, what? Uh, okay. What? Uh, okay. I mean, it's just for you. Um, it's the same idea as the other ones. With uh, it's the same idea with the n square algorithm, where it uses the dynamic programming to do it that way. Um, eh, that's clever, and then to get zeros and then sum up all the counts in between. That's a pretty clever way of doing it. I was actually thinking about something similar for n square, but I couldn't come up with it during the contest, or at least I didn't want to spend more time coming up with it, so I YOLO'd a little bit. Okay, Q3. What was my Q3? Oh yeah, that's the tree one. Okay. No, this is way too long. This is way better. Yeah, so I think I actually noticed this, and I didn't mention this because I didn't do it that way. But because it is a tree, it is good enough that when you do a depth first search, um, that you don't go up the tree. And what I mean by that is that And what I mean by that is it's good enough to just keep track of your parent. So, and then not go to your parent, so that you always go downwards. So that's a common recursion thing. But unfortunately, I wasn't able to remember that one. I guess it's been a little bit, and I need more practice on that one. But I mean, I did something else, which is okay, but not great. Um, but yeah, but same idea, except my implementation is bad. So I did learn that I could do that. So that's kind of cool thing to learn or relearn. I think I used to do it, but I don't know. Today implementation is not my skill, and a lot of people you see are doing the parent trick. Um, yeah, yeah, okay. Could have done it that way as well. I should have. There are a couple of ways I could have done it. I did it a silly way, and yeah, and this is wow, they're really short. Uh, and that makes sense actually. And instead of using non-local or something, use that, but that's another story. Okay, Q4. I mean, that's just DP straight up for me. Let's see if there are any other cool solutions. Got in 5 minutes. That's great. Okay, just DP without the whatever minus memo. What does that mean? I don't know what minus does. I'll just query it so that could call the recursion. Okay. Um, and this is the prefix sum. So I guess that's wow. I guess this is standard for the top people. I'm not surprised. I wonder if there's an easier way. Because a lot of people finish this pretty quickly. Also DP. Yeah, I guess there are not that many ways to write DP if that's the way to solve the solution. Um, but apparently, oh, I guess I guess what this does is implicitly, like, but apparently you don't even need prefix sum. So that's what I learned about this because you just do two full loops. I thought about this, but I was a little bit worried that I might need it. But they must do some other things. But I don't know. This feels a little slow, but maybe not. Clearly, n times m times n times m times cuts times k, that is fast enough. I thought that would be too slow. So apparently that would have saved me some time, but still wouldn't save me the 5 minutes because I mistyped LRU cache. But I mean, I took 20 minutes on that one, which is not fast, but not that, like, it's okay. Like, other people did it really fast, but I had off by ones and stuff like that. So I think if I didn't have the LRU cache error, I would have been happy with that one. But, okay. Cool. That's all I have for code reviews. Let me know what you think about this section. I don't always do it, but, you know, it's always good to get feedback if don't complain too much. Anyway, I hope you had a good contest. Hope the explanations were okay. Let me know if you have any questions. Leave a like, hit the subscribe, and I will see you next contest. Bye bye.